This is a triple science video from the topic B5 looking at kidney dissection. So we're going to take this kidney, dissect it, and also discuss what happens inside the kidney. So the primary function of the kidney is to filter the blood. Any of those amino acids that we've eaten from digested proteins that aren't used by the body to build up new proteins go to the liver. In the liver, they become ammonia, and then they are quickly converted from ammonia, because it's toxic, into urea. And that urea then travels through the blood to the kidneys, and in the kidneys it becomes urine. So let's have a look at our kidney. This is a pig kidney, quite solid, and we're going to, you can see obviously it's got that kidney bean shape to it, and we're going to be cutting down this outer side here using my scalpel. And I'm going to cut, not like I'm cutting with food. I'm not going to hack backwards and forwards. Really sharp blade here, and I'm just going to cut through. So already just with the first cut, you can see I've cut quite a lot, a good 1.5 centimetres of depth into the kidney, and we can already see some of the tubules there. They're called nephrons, just inside there. We'll have a better look in a minute, but we're going to call them tubules. Just taking my time, really sharp blade here, so just wanting to cut as gently as possible. And just take this top off like a lid. Now inside this kidney there are thousands, if not millions, of these tiny tubules, okay, called nephrons, but we just are going to learn them as tubules, and they filter the blood. Okay, and we'll talk through how they do that in a moment. I'm getting through that quite nicely now. Okay, so see all those tubules are down here, the thousands and millions of them, okay, and they all filter up and join into larger branches until we get to the ureter. I'm just going to discard that bit. So there is my kidney, and if we refer to the picture here, we can see here is that central point where all of the, it's not the best kidney in the world to be honest, it's where all of those tubes will filter in. Okay, so we've got all of these tubules down here, and to reveal those a bit better, I'm going to use some hydrogen peroxide. Give that a bit of a fizz. This is going to take away some of the flesh of the kidney, so that we can then see, reveal those tubules. We've got these kind of sections here, I'll just point them out. These are medulla. Okay, in between, and we can kind of pull some of those out. Have a go at doing that to show you. Just scrape off that hydrogen peroxide, and you can see, hopefully, I'll zoom in a second, you can see those tubules a bit better. All these faint white lines are all these thousands and thousands of tubules all filtering the blood. So I can take one of these medulla and just cut through that. Remove that to reveal some of the networks where these tubules feed in, all feeding in eventually to the ureter. Okay, so So let's just maybe just put a small amount more of that on. And scrape that off. There we go. We've got a really good view there of those tubules. Okay. I'm going to zoom in so you can see a bit better. Okay, we can bring it slightly closer and you can see all of those tubules. Okay, and if I just zoom out again, let's talk through some of that theory. So as I said already, the amino acids that aren't used in the body go to the liver. They are deaminated to become ammonia. Because ammonia is toxic to the body, they're immediately converted to urea. That urea then goes to the kidneys, and we've got a picture here on the right with a tubule there, known as a nephron, but we're going to call it a tubule. And they have lots and lots of capillaries very close by, and this allows substances to move from the capillary into the tubule and back again. So we've got three main processes. We've got filtration, and as you can see on the picture, anything that is small enough to move across from the capillary to the tubule will. The main things being water, ions, urea and sugar. Okay, and then it's about the tubule saying, right, I've got everything in here, what do I want back in the blood? What's going to be useful to get back into the blood? So we get to stage 2, which is selective reabsorption, and we will have the amount of water that's needed to go back into the blood. So if you're very hydrated one day, not all of the water will go back into the blood, an appropriate amount will. If you're very dehydrated, then more water will try to be clawed back to keep you hydrated. So water, an appropriate amount will be pulled back into the capillary in that selective reabsorption. Again, with the ions, an appropriate amount to keep that homeostasis will be pulled back into the capillary there, and all of the sugar. Okay, so all of the sugar that goes into that tube will be selectively reabsorbed back into the capillary. Now, going through the capillary away from the kidneys, we've got most of that water, most of the ions and all of the sugar. And then we get to stage 3, which is the formation of urine. This is all of the urea and any of that excess water and ions that came out of the blood. Okay, and this will go as urine to the bladder. Okay, now we've got some active transport taking place here, so there's a lot of mitochondria present supplying that energy through respiration for active transport to take place. The glucose going back into the capillary from the tubule in selective reabsorption uses active transport. Also the ions going back in is active transport. Water movement there by osmosis. Okay, hope you found that useful. Thank you.